Right, so this is section 8.5. So law of sines is one way that we're going to use trigonometry on a triangle that's not a right triangle. So the first thing we need to do is talk about how we label triangles. So this is just some generic triangle, nothing special about it, no 90-degree angles, no special angles. We label angles with capital letters. And we label the sides across from those angles with small letters. So this would be side A, across from angle A. Side B, across from angle C, or sorry, angle B. And side C, across from angle C. So the small letters are the side lengths. So the capital letters tell us about angles. Small letters tell us about the sides, and we always label the sides across from the angles. So law of sines, nice easy equations. For any triangle, ABC, we get these equations. Sine of A over A equals the sine of B over B equals the sine of C over C. And let me make that C small. So we can also do the reciprocals of these. We can say A over the sine of A equals B over the sine of B equals C over the sine of C. And the way we come up with these is we divide this triangle, we draw in the height. So we divide it into two right triangles, and we use our regular SOHCAHTOA trigonometry on those right triangles to come up with these equations. So that's where they come from. Did I start? Yeah. Now this gives us, when we write the equals in between like this, we get three equations. This is just a shorthand way for writing three equations. We get 1 sine A over A equals sine B over B. That's one of the equations. One of them is sine B over B equals sine C over C. And the third one, I can combine the first one and the last one. Sine A over A equals sine C over C. So law of sines gives us three equations. Yeah.
Do you only use sine or you use sine plus sine?
For law of sines, we only use sine. So that's one thing that makes law of sines nice, is you just use one thing. And what we set up here are proportions. And we know how to solve proportions. We solve proportions by cross multiplying. So often, when once students learn law of sines, they want to use law of sines for everything. They don't want to use anything else because law of sines is pretty easy. On the test, there will be some problems where you have to use law of sines. Those are the only ones that on the test that you can use law of sines on. The others, you have to use SOHCAHTOA on a SOHCAHTOA problem. You have to use special right triangles on a special right triangle problem. You have to use Pythagorean theorem on Pythagorean theorem problems because we want to see that you know how to do all of those things. All right, so what I want to do is just go through a couple of examples of setting up a problem using law of sines. So what we call this, we call it solving triangles. Solving just means finding missing parts. We use law of sines for when we have two angles in one side. So those triangles would be an angle side angle triangle or an angle angle side triangle. That's when we have two angles on the side. We can also use it for two sides and an opposite angle. And that would be an SSA. And I'm going to put a little asterisk there. So I want to talk about the SSA triangle right at the end. All right, so let's look at some examples. Here's my triangle, just a generic triangle. And these triangles not drawn to scale. And I'm going to call this, we'll say A, B, and C. And we'll say side A is 3, angle A is 25 degrees, and angle B is 70 degrees. And we want to find B and C. So we want to find those two missing sides. Here we have two angles and a side. Now the way we use law of sines is we want to make a ratio with an angle and the side across from it. So one piece of my equation for this problem, since I know these two, I would say the sine of 25 divided by 3. And we're going to set that equal to a ratio that we make from another side and another angle. So since we have angle B, I'm going to say match that one with this. So we match the angle with the side across from it. So I'm going to say that equals the sine of 70 over B. And B is what we're trying to find. So we make ratios with the angle, the sine of the angle, and the side opposite. And we set them equal to each other. And we know we solve these proportions by cross multiplying. So I'll cross multiply here. B sine 25 equals 3 sine 70. Now you could, if you wanted, plug these into your calculator and turn these into numbers now to calculate with. If you do that, you need to keep 4 decimal places, because your answer can end up being way wrong if you don't keep 4 decimal places. I like to calculate right at the end. So I'm going to divide everything by sine 25 to get B by itself. So those cancel, and I get B is 3 sine 70 divided by the sine of 25. And you can put this in your calculator just like this. So let me go to my calculator. I'm going to do 3 sine 70. And you just have to remember to close that parentheses there. Divided by sine of 25. Close that parentheses, enter, and I get 6.67. And I'll round to the 10th, so that would be 6.7. So we figured out that B was 6.7. Yeah.
So when you do it to the calculator, you just do 3 and then that, and then divide it by sine 25.
Uh-huh. Yep, 3 sine. You could put a times in there, but it does a multiplication automatically. Just be careful. Make sure you put the parentheses after that 70. Otherwise, your calculator will give you a crazy answer. All right, now we need to find side C. So we need to match this angle. We need to make a ratio with this angle on that side. I'm going to use this one again since we already have that one. So I'm going to say that sine of 25 over 3 equals, but I don't know this angle. What am I going to do about that? Right. We have two of the angles in the triangle, so we can figure out angle C, right? Angle C is 180 minus 25 minus 70. All the angles have to add up to 180. So I add 25 and 70 and subtract from 180, and I get 85 degrees. So that's what I'm going to use in that ratio. So that's going to be sine of 85 over C. And we solve this the exact same way. Cross multiply. C sine 25 is 3 sine 85. I want C by itself, so I divide by sine of 25. Those go away, and I get C equals 3 sine 85 over the sine of 25. And I'm going to put this in my calculator, just like this. So 3 sine 85. Make sure I close off that parentheses. Divided by the sine of 25. And I get 7.07. And if I round that to the 10th, I would round the 0 up since that's bigger than 5. So 7.1. So there's side C, 7.1. And we would say then that we've solved that triangle. We found all the missing pieces. So the key to using law of sines is match the angle with the side opposite. And we always use sine for law of sines. That's why it's called law of sines. Questions? All right, I want to set up one example where we have to find an angle. So here's my triangle. Whoops, that's not what I wanted. I wanted this. We'll call this X, Y, and Z. And we'll say angle Y is 45 degrees. This is side Z. Side X, we'll say, is 25, and side Y is 30. So this one we have two sides and an angle opposite. So we can use law of sines. And we want to find the measure of angle X. So we're going to match up that angle with that side. And since we have these two, an angle in the side opposite, I'm going to use that angle and that side to set up my ratios. So I'm going to say the sine of, this time we're looking for an angle, so the sine of X over 25 equals the sine of 45 over 30. So I have these two sides, or this angle and this side. So I want to make a pair with those two. And we're looking for this angle, and I have this side, so I want to make a pair with those two. And X, sine of X, angle X is what we're looking for. So I want to get sine of X by itself. This time all I have to do is multiply both sides by 25. And those go away. I get the sine of X equals 25 sine 45 over 30. Now I'm looking for an angle. when we're looking for an angle, what do we have to use? We have to use the inverse. Nice. So we're going to say use inverse. So x is going to be the inverse sine of this whole big thing. 25 sine 45 over 30. And we can put it in our calculators exactly like this. If you have a TI calculator, put it in exactly like that. So I'm going to say, clear that off, inverse sine, and then I had 25 sine 45, close off that parentheses, divided by 30, close off that parentheses, and hit enter, and I get 36.1. So that angle would be 36.1 degrees. Now we could do, there are a couple of ways that we could calculate this in without putting it all in at once. I could calculate 25 sine 45 divided by 30. So I could do 25 sine 45, close the parentheses, divide by 30. And that says 0.058925, And on your calculator, you can do the inverse sine of the answer. Above this negative sign is the answer button. Hit enter, and I get 36.1. Or when you see this on your screen, the 0.5892, I could do the inverse sine of 0.589. I would round this up to 3. And I want to do 4 decimal places, and hit enter, and I get 36.1. But notice how when I rounded this one off here, my numbers start to change a little bit. And if I just did 0.6, let me do that. If I rounded this to 0.6, inverse sine of 0.6, I get 36.9. So that's quite a bit different. So that's why you want to keep 4 decimal places. All right, questions there? All right, really quickly, for side-side angle. Triangles. Sometimes we can get 2 triangles. And if you remember back to when we were talking about showing that triangles were congruent, we said we couldn't use side-side angle as a way to show triangles are congruent. And that's because we drew a picture like this back then too. If we know angle A, and we know side A, and we know side B, so we know this angle and those 2 sides, we can swing that side around in a little circle, pivot it right here, and it connects up with the base of that triangle right there. And here is another triangle with side A, side B, and angle A. So I get this triangle, this little thin triangle, and I get this bigger triangle that both have the same angle and the same sides. And we have to figure out which of those possibilities. For law of sines, we'd have to take into account both possibilities. We call this the ambiguous case. In this class, all I really want you to know is that the ambiguous case exists. We won't have to do anything with it. In Algebra 2, and especially in pre-calc, you'll learn about the ambiguous case and how to figure out if you have the ambiguous case and how to figure out what the lengths of the triangles are if you do. For now, I just want you to know that sometimes for a side-side angle triangle and the law of sines, you can get what we call an ambiguous case. But for us, that's all I want you to know, is that you can't. It's possible to get it. We won't have to do anything with it. So when you see it in Algebra 2, you'll say, oh yeah, I remember something about an ambiguous case. All right, questions? Okay. So we are going to